succeeded independently in giving a satisfactory explanation about this. They were the first to provide some logical explanation of valency. What is that logical explanation? Especially to the gases, noble gases. Lewis pictured the atom in terms positively charged, isn't it? Now, kernel, the nucleus plus the inner electrons and outer shell that could be accommodate a maximum of 8 electrons. Here I am talking about atoms in terms of positively charged. Kernel, which is nothing but the nucleus plus inner electrons, and outer shell that could be accommodate a maximum 8 electrons. See, he further assumed this 8 electrons, whatever we have, they occupy the corners of cube which surround the kernel. Okay, corners of the cube. Thus, single outer shell, single and outer shell, whatever we have, generally that are having electrons of sodium. Okay, and one corner of the cube, which while in the case of noble gas, all the 8 corners would be occupied. If you wanted to understand this logical statement, we have a diagram I will show to you. This octet generally resembles the statement says about the octet. Octet of electrons represent a particular stable electronic arrangement. This arrangement gives a stability. If you take the diagrammatical representation, lithium has 1 electron, barium has 2 electrons, beryllium has 2 electrons, barium has 3 electrons, and carbon has 4 electrons. This says the specific electronic configuration of the specific element. Now, Lewis postulated that atoms, whatever there, that achieve stability or stable octet when they are linked by chemical bonds. So these chemical bonds are necessary to attract them in a specific place. In the case of sodium and chlorine, this can be happen by the transfer of an electron from sodium to chlorine, thereby giving them specific shape. So let us take with an example, I would like to explain this. Sodium plus and let us take chlorine is there, Cl minus ions. Now, in the case of other molecules like Cl2, H2, F2, these bond is formed, generally these are formed by the sharing of a pair of electrons between the atoms. In the process, each atom, whatever we have, attains a stable outer octet of electron. Now finally what I am telling, if you take a Lewis symbol, in the formation of a molecule, if you take a molecular formation, only the outer shell, whatever we have, the electrons that are present in the outer shell take part in the chemical combination, and there are known as valency electrons. Here I have a clear definition for valency electrons. Only the outer shell electrons take part in the chemical combination. They are helping in the formation of some chemical compounds. Combination in the sense compounds, and they are known as valency electrons. What about the inner shell? If you take inner shell electrons, they are protected and are generally not involved in the combination process. So inner electron shells do not play any role in the formation of combination or compounds. So based on this, G.N. Lewis, a great scientist, an American chemist, introduced similar notations or simple notations to represent a valency theory or valency electrons in an atom. These notations are called Lewis symbols. Let us take some examples. Lewis symbols for the elements of second period are under significance of Lewis symbols. The number of dots around the symbol represent, specifically, let us understand, the number of valence electrons. Now, this number of valence electrons helps to calculate the common group valency of the element. Now, the group valency of element is generally, if you take a general combination here, equal to the number of dots, So valency of elements is generally either equal to the number of dots in Lewis symbols or 8 minus the number of dots or valency electrons. So finally, question in relation to chemical bonding, draw attention to the following facts. What are they? Let us see. In the periodic table, if you carefully see, highly electronegativity or electronegative halogens and the highly electropositive alkali metals are separated by the noble gases. Now, the formation of, if you take this statement, very important, the formation of a negative ion from a halogen atom, see, which means a negative ion, it is going to be formed from the halogen atom, and a positive ion is going to be formed from the alkali metal atom, is associated with the gain and loss of an electron. So by the respective atoms. Finally, the negative and positive ions, whatever we have, ions like chlorine is a negative one and sodium is a positive one, thus formed, attain a stable noble gas electronic configuration that we are going to see here. Now, the noble gases, as you know, that zero group elements, with the exception of helium. If you take a helium is also a zero group element or a noble gas, but exception is given for helium, which has a duplet of electrons, which have a particularly stable outer shell configuration only with 8 electrons or octet, which means if there is a octet rule or octet formation, which means it indicates 8 electrons will be going to be formed with the configuration ns2 and np6. Here you can see, so 2 plus 6, 8 electrons going to see octet structure configuration. Negative and positive ions are stabilized by electrostatic attraction. There must be a electrostatic attraction between negative and positive ions, which helps to stabilize them. For example, the formation of sodium chloride from sodium and chlorine according to the above scheme can be explained as, here Na, if you take a sodium, Na plus, it is the positive ion and electron as usually. What about chlorine? So if you take the zero group element, here in the above statement I said to you now, noble gases and their help in the formation of electronic configuration. The electronic configuration as per the periodic table and with the help of zero group elements or noble gases. So the electronic configuration for sodium I am going to take you here 3s1 and neon I am going to add here. What about chlorine here? Chlorine plus electron and it is a negative ion. Chlorine is a negative ion and zero group element electronic configuration will be neon 3s2 3p5, neon 3s2 3p6 or argon going to be given. This kind of configuration helps to understand the electrostatic force between the various ions. Now Na plus Cl going to be Na plus Cl going to be combined together, and finally it leads to formation of sodium chloride or sodium plus chloride. Similarly, it is a common salt. The formation of CaF2, if you take CaF2, calcium fluoride, may be shown here. Ca2 plus, which means positive ion and 2 electrons are generally there, and organic configuration here it is given. Argon plays an important role in the electronic configuration of calcium. Argon plus 4s2. And what about fluorine? F plus electron gives rise to fluorine. What is the zero group electronic configuration? Helium is generally added to that, 2s2 2p5 and 2s2 2p6 or neon generally added. So the final bond formation in between them, Ca2 plus plus 2f gives rise to CaF2 and Ca2 plus. Now finally what I am telling to you, The bond formed as a result of the electrostatic attraction between the ions or positive negative ions was termed as the electrovalent bond. What is that bond called? Electrovalent bond. The electrovalence is thus it is generally equal to the number of unit charges. It is equal to the number of unit charges on the ion. Finally, what I am telling to you, let us take the calcium is assigned as a positive electrovalency of 2, while the chlorine, if you take as a negative electrovalency of 1. Now, Cosel's postulated that and provided a basis for formation of modern concept of electron transfer and the formation of ionic crystalline compounds. Ionic crystalline compounds I will explain to you in the further topics, and his view, Cosel's view, have proved that a great value in the understanding and systemization of the ionic compounds, how ionic compounds are going to be formed. At the same time, he did recognize the fact that a large number of compounds did not fit into these concepts, but it is only applicable to some of the elements and compounds. Now we are going to learn one more rule called octet rule. What is octet rule? According to the Cosel and Lewis in 1916 developed an important theory of chemical combination between atoms, okay, known as electronic theory of chemical bond. This electronic theory of chemical bond also depends upon the attractive forces present in between the atoms. Atoms can combine either by transfer of valency electrons or from one atom to another atom, or by sharing a valency electrons that are there on the outer shells in order to have an octet. This is known as octet rule. Next one is covalent bond. What is covalent bond? Langmuir refined as Lewis' postulations by abandoning the idea of stationary cubical arrangement. He just abandoned in the sense he doesn't agree properly the idea of a stationary cubical arrangement of octet, which means he introduced the term covalent bond. What do you mean by covalent bond? Covalent bond was introduced by Langmuir in 1919. Lewis-Langmuir theory can be understood by considering the formation of the chlorine molecule. So he took example chlorine, which is a negative ion, and chlorine atom, if you carefully see, with electronic configuration, and a neon plays an important role here. 3s2 and 3p5 will be there, and it is one electron short of organic configuration. And the formation of chlorine, if you carefully observe, it is can be chemistry chlorine atoms attain the outer shell, attains outer shell, and outer shell octet of the nearest noble gas, and nearest noble gas to that is definitely argon. The dots represent the electrons here. I already told you now. Such structures are referred as a Lewis dot structures, which means each dot represent one electron. Lewis dot structure can be written in the for the formation of molecules in which atoms are going to be formed and may be identical different. And the important conditioning I will mention here: each bond formed as a result of sharing of an electron pair between the atoms. Now, each combining atom contributes at least one electron, to the shared pair. The combining atoms attain the outer shell noble gas configuration. As a result, sharing of electrons will be occurring. Thus, in water and carbon tetrachloride, if you take in the carbon tetrachloride molecule, formation of covalent bond can be represented as understood in terms of sharing of pair of electrons. When the electrons are going to be shared, what will happen? It leads to formation of covalent bonds in between the chlorine atoms. Each chlorine atom contributing one electron to a shared pair in the process of both shells. I will show you here and covalent bond between two atoms. Here we have taken example chlorine Cl minus Cl minus, and as you can see here, chlorine is generally forming negative ions. So here dots represent number of electrons, okay, and you can see the octet structure, and plus one more chlorine, and you can see the number of electrons here, okay. Now if you carefully observe chlorine, how they forms, chlorine ions, how they forms, okay, atoms. Let us take one of the atom here, and this is one of the atom, and this is also one of the atom, and here number of electrons I am mentioning, okay. Here this is one of the bond, imagine that. This is also one of the bond, and where are valence electrons? These are valence electrons. By sharing these electrons, okay, a bond formation will be occurring in between them called as a covalent bond. This gives a specific stability for chlorine atoms. One more example I would like to give you. In case of water, let us take water. How many hydrogens are there here? Two hydrogens are there. H with 2 electrons, and let us take oxygen atom. How many electrons will be there? 8 electrons will be there, and bond formation will be occurring in between one hydrogen and another oxygen. And oxygen, how it is going to form the bond with hydrogen, you can see here, and another hydrogen, how it is going to form bond with this oxygen atom, you can see here. Sharing of these electrons, the valency electrons present on the outer shells, helps to form a specific bond called a covalent bond. Here hydrogen atom attains a duplet of electrons. Duplet means two electrons are going to be attained, and oxygen contain octet. Octet means 8 electrons will be there. Here 6 are there, here 2 are there. Total 8 electrons are there. Now let us take each of the 4 chlorine atoms along with the carbon atom attains an octet rule. In case of carbon tetrachloride, CCl4, that is the structure. Now I would like to represent here, carbon is a central atom and main atom, and chlorine is here, and chlorine, one more chlorine will be here. Why? Because total 4 chlorine molecules are there, and one more chlorine here will be there. And as you know that number of electrons you can mention in the form of Lewis dot, and valence electrons you can mention here, and the number of electrons for chlorine I am mentioning here, and valence electrons I am mentioning here. So number of electrons you do mention here, and valence electrons I am mentioning here, valence electrons, okay, and you can see here how this bond formation occurs in between the carbon and the chlorine atoms. If you carefully see, carbon is going to be formed, carbon is going to attach to the chlorine atoms by each of the chlorine atoms along with the carbon atom attains octet of electrons. Total 8 electrons are there in the valency shell. Now this type of covalent bond, as usually you can see in a CCl4, okay, carbon tetrachloride, it is commonly called carbon tetrachloride. Each chlorine atom is going to connect to valence electrons that are there on the outer shell. These are called valence electrons present on the outer shell. Like this, covalent bond is going to be formed. This kind of bonding is commonly observed with 8 electrons. Here 8 electrons are there for this chlorine, 8 electrons are there for this chlorine, 8 electrons are there for this chlorine, 8 electrons are there. Finally, thus when two atoms, if you carefully see, when these two atoms share one electron pair, they are said to be joined by a single covalent bond. They are said to be joined by single covalent bond. And whereas if you see, in many compounds we have multiple bonds between the atoms. Let us take compounds. Compounds contain different types of atoms. Compounds contain different types of atoms with multiple bonds. The formation of multiple bonds envisages sharing of more than one electron pair between two atoms. Finally, what I am telling you, if two atoms shares two pairs of electrons, the covalent bond between them is called double bond. If two electrons or two atoms shares two pairs of electrons, the covalent bond between them is called double bond. Okay. Whereas if two atoms shares three pairs of electrons, the covalent bond between them is called triple bond. For example, carbon dioxide molecule is there, CO2. We have two double bonds between the carbon and the oxygen atom. Similarly, ethane, if you take ethene molecule, two carbon atoms are generally there, and in between the two carbon atoms are joined by a double bond. So we are going to see now double bond formation in case of CO2 and in case of carbon dioxide molecule. Okay, carbon is the central molecule in CO2. Okay, outer shells, valence shells I am mentioning here, electrons you can see here, oxygen you can see here. Okay, you can see the oxygen here. Here also you can see the oxygen. Okay, here also you can see the oxygen. Now let us see how bond formation occurs. Now oxygen with valence electrons, and here also oxygen with valence electrons. What about carbon? Carbon is going to be joined with the oxygen along with the sharing of valence electrons. This kind of bond formation also can be referred by following: oxygen, as you can see here, and electron sharing I would like to mention, and another oxygen atom along with the electrons. Here oxygen along with these dots mentioning two pairs of electrons. How many? Two pairs of electrons. Here also two pairs of electrons are there on the outer shell. When these outer shell valence electrons are shared to the carbon, then bond formation occurs. So two pairs of electrons are going to be shared, hence it is called double bond. What is that called? Double bond. So finally what I am telling to you, you can see here along with that chemical bond formation and molecular structure in between ethene C2H4. So carbon is a centralized molecule. Here also carbon is centralized molecule, and outer shell electrons I am going to mention here, and here also outer shell electrons are going to be mentioned here. Outer shell electrons are going to be mentioned here, and here hydrogen will be there. Here also hydrogen will be there. How many hydrogen molecules are atoms are there? 4 hydrogen atoms. So how bond formation occurs? In between these two valence electrons and hydrogen atom. In between these two valence electrons and hydrogen atom. Okay, at the same time, in between these two electrons, valence electrons and hydrogen atom, in between these two valence electrons and hydrogen atom. Finally, if you take the carbon, how it is going to be joined together. So here carbon is going to be joined like this, and the second carbon also going to be form a bond in between the hydrogen atoms like this. This type of bonding is called as a covalent bond, which is also can be represented like this: CH, here also CH, and a double bond formation, as you know that two pairs of electrons, valence electrons are shared. So double bond formation occurs, or duplet formation occurs. This kind of structure chemically represented as C2H4. Finally, what I am telling you, when combining atoms share 3 electron pairs as in case of 2 nitrogen atoms in the nitrogen molecule. The 2 carbon atoms in the ethane molecule, a triple bond is going to be formed. I told you now. So sharing of 3 electron pairs in the case of 2 nitrogen atoms, going to see with the triple bond formation. So N2 I have taken here, nitrogen I have taken here, and how many valence electrons, outer shell electrons are going to be shared? 3 pairs here. As a result of it, nitrogen atom along with 3 pairs of electrons. Nitrogen atom along with 3 pairs of atoms. Going to see with 8 electrons are given here. 8 electrons are generally seen here. 2 plus 6, 8 electrons. Here also 2 plus 6. This is one pair of electron, this is a second pair of electron, third pair of electron, and nitrogen having inner shell 2 electrons. Inner shell electrons do not play any role in the bond formation. So finally, this is also can be represented as nitrogen with a triple bond formation and N2 molecule. Got my point? So everybody understood what is a triple bond formation. Triple bond formation in case of a C2H2 molecule. Carbon is a centralized molecule here, ethane, okay, and inner shell electrons I have mentioned here. Outer shell electrons you have to mention here in case of ethane, and second carbon inner shell electrons, and hydrogen I have mentioned here. Here also I have mentioned hydrogen. You got my point? Now hydrogen along with these 2 electrons, okay, and carbon along with this, okay, and next carbon along with this, okay, and hydrogen along with this kind of bond formation, okay, you can see with a combination of 8 electrons. Here 6 electrons are there, each dot represent 1 electron. Here 6 are there, here 2 are there, 8 electrons. Here also along with this bond, carbon generally having 8 electrons in this chemical bond formation. Now this is in case of C2H2, commonly known as ethane. Now one more thing I want to say, Lewis represent simple molecule, Lewis structure. Lewis dot structure provide a picture of bonding. What is that picture of bonding? A bonding formation in case of molecules, okay, and ions in terms of the shared electrons or pair of electrons in case of octet rule. While such a picture may not be explained the bond formation and behavior of a molecule, it does helps in the understanding formation of properties of a molecule. So the properties of molecule depends upon the bond formation. Why? Because it defines metallic and non-metallic characters. Writing of Lewis dot structure of molecule is therefore very useful. The Lewis dot structure can be written by adopting the following steps. What are they? The total number of electrons required for writing the structure are obtained and adding the valency electrons. These are very, very important of the combining atoms. For example, in the CH4 molecule, there are 8 valence electrons available for bonding. 4 from carbon and 4 from hydrogen. 4 hydrogen molecules. Okay. Now, hydrogen atoms. For anions, each negative charge would mean addition of 1 electron. Okay. Chlorine is there. Addition of 1 electron to the chlorine. For cations, if you take a sodium, addition of each positive charge result in the subtraction of 1 electron. So chlorine receives 1 electron during an anion formation, while positive ions, positive charge if you see, would result in the subtraction, which means removal of 1 electron from the total number of valence electron. For example, one more example I am taking, CO3 2 minus ion is there. The two negative charges here, two minus represent, indicate that there are two additional electrons than those provided by the neutral atoms. Additional electrons are there here. Whereas if you take NH4 plus ion, one positive ion charge indicate a loss of one electron from the group of neutral atoms. Knowing that chemical symbols, if you carefully see, combining atoms whatever we have, having the knowledge of skeletal structure of the compound known as guessed intelligently, it is easy to distribute the total number of electrons as bonding shared pairs between the atoms in proportion to total bonds. Now, in general, least electronegative atom occupies the central position in molecular ion. For example, NF3, nitrogen fluoride, is there, okay, and CO3 minus 2 is there. These two ions, if you carefully see, nitrogen in case of NF3, carbon in case of CO3 minus are the central atoms, whereas fluorine and oxygen are occupying the terminal positions. And finally, after accounting for shared pair of electrons, if you see carefully, single bond whatever we have, single bonds remaining the electron pairs are either utilized for the multiple bonding, remain as the lone pairs. Finally, basic requirement being that each bonded atom gets an octet of electrons. Each bond gets an octet of electrons. Lewis representation as a few molecules, ions, are given in table number 4. I will show you that table here. Lewis representation of some of the molecules. H2 in case of molecule H2, and H dots, two dots are given here, okay. So what is that represent? Two valence electrons are present here. So the bond formation in between them, single bond formation, Lewis representation. So this is Lewis representation. Now in case of O2, how many electrons are there in and around it? If you carefully see, octet rule, how many electrons are there here? You can carefully see here, okay now. So this on the Lewis dot formation, how it will be there? It will be like this. And bond formation, double bond formation. Why? Because two pairs of valence electrons are going to be shared. And what about the next one, O3 and NF2? Let us take NF2 or NF3. Let us take NF3. So nitrogen is the central atom, and you can see the electrons of nitrogen and fluorine electrons. Here also Lewis dots you can see, okay. Here also you can see the fluorine, okay, and dots represent pairs of electrons. Here also fluorine, one more fluorine atom. Dots represent number of electrons, and bond formation will be N, F, F and F. Single bond formation generally same, okay. And remaining examples you can go through them. Finally, problem number 1. I have some problems but not all the problems. Remaining problems I will discuss with you later on. Write the Lewis dot structure of carbon monoxide molecule. Here, solution, step number 1. Count the total number of valence electrons of carbon and oxygen atoms respectively. So we have to count the valence electrons. The outer valence shell configuration of carbon and oxygen atoms are, if you take a 2s2, 2p2, that is the outer shell configuration. Why? Because S and P are outer shells. Whereas for oxygen it will be 2s2, 2p4. Total number of electrons in oxygen 8, okay, respectively. So but in the outer shell there are only 6 electrons are present. In inner shell 2 electrons will be there, okay. Finally, the valence electrons available are here 4 plus, here 2 plus 4, 6, total number 10. Okay. Step number 2, skeletal structure of CO. Can you remember carbon monoxide is written as CO. Okay. Draw a single bond, one shared pair electron between carbon and oxygen. Complete the octet on the oxygen. The remaining 2 electrons are lone pairs on carbon. Okay. So draw the diagram. Here I am drawing the diagram. Carbon container, you can see the electronic configuration. Oxygen generally an octet atom. Why? Because it follows the octet rule. Hence it is an octet atom. And it is also can be represented as octet is nothing but 8 electrons generally present in its skeletal structure. Carbon with single bond formation, okay, and oxygen, as you can see here, it will be like this, and a single bond you have to mention like that, and the answer you have seen that. This does not complete the octet of carbon, octet on carbon. Hence we have to resort to multiple bonding in case of triple bond between carbon and oxygen atoms. Okay, this octet rule condition for both atoms we are going to see. If you carefully see carbon here, okay, 3 pairs of electrons sometimes are going to be shared with the oxygen. Hence it follows the octet rule. Okay, this kind of octet rule helps to form triple bond. Why? Because 3 pairs of valence electrons are shared in between the 2 atoms. Hence, as a result of it, 3 bonds are going to be formed here. So you can see clearly how triple bond is generally looks like. Now solution, step 1. What will be the solution for that question? Count the total number of valence electrons of the nitrogen atom. We have to find out valence electrons and atoms and number of valence electrons of the nitrogen atom. The oxygen atoms and the additional one negative charge equal to 1 electron. Now let us take it. Nitrogen is there and it will be 2s2 2p3. Okay. In case of oxygen, 2s2 2p4. Okay, and it will be 5 here, and 5 plus, and 2 into 6, how much it is? As you know that 12 plus 1 equal to, and together if you count, 18 electrons are going to be seen. You got my point? Now step 2, the skeletal structure of NO2, nitrogen dioxide, minus is written as NO. Why? Because 2 oxygen atoms are there and central molecule will be nitrogen. And draw a single bond, one shared pair between the nitrogen and oxygen, each of oxygen atoms. Okay. Now this however does not complete octet on nitrogen if the remaining 2 electron constitute lone pair of it. So nitrogen I am going to mention here, and oxygen I am going to mention here, and oxygen also here also I am going to mention here. Okay, so dots, each dot represent an electron. Hence we have to resort multiple bond between nitrogen and one pair of oxygen atoms in case of double bond. This leads to following Lewis dot structure. You can see in the diagram clearly how this Lewis dot structure looks like. Okay, in case of NO2. Finally, formal charge. What do you mean by that? Lewis dot structure in general do not represent the actual shape of the molecule, but in case of polyatoms or polyatomic ions, poly means many atoms and their ions, the net charge is possessed by ion as a whole and not by the Lewis dot structure, nitrate ion like NO2 minus a particular atom. Now it is however feasible to assign a formal charge on each atom. The formal charge of each atom in a polyatomic molecular ion may be defined as difference or basic difference between the number of valence electrons of that atom in an isolated area or a free state and the number of electrons assigned so far. Formal charge, if you carefully see the formal charge Fc, abbreviation for Fc, formal charge, an atom in a Lewis dot structure. Total number of valence electrons in the free atom minus or total number of non-bonding lone pair of electrons minus 1 by 2 into total number of bonding shared electrons, together generally called as formal charge. Counting is based on the assumptions or the idea of imagination that the atom, if you carefully see, in the whole molecule owns one electron of each shared pair, both electrons of lone pair. Let us consider the ozone molecule O3. The Lewis dot structure of O3 may be drawn as, you can see the Lewis dot structure for ozone molecule. This is the first molecule, okay, and bond formation, if you see, to this in between first atom and second atom of oxygen, double bond is commonly seen, which means two pairs of valence electrons shared between first oxygen atom and second oxygen atom. And whereas if you carefully see third oxygen atom, it is only a single what we can call single bond formation, because one pair of valence electrons shared in between first oxygen atom and the third oxygen atom. Finally, the atoms have been numbered as 1, 2, 3 in the given diagram. Formal charge on them is respectively starting with the oxygen atom marked with 1 equal to 6 minus 2 minus 1, okay, and 2 into 6 equal to plus 1. The value is plus 1. This is the formal charge of O3. Based on the electrons and electronic configuration, we can take the, and I told you the for formal, if you want to find out the formal charge of a specific element, we have a formula for that. In the previous slide I have shown to you. The end of oxygen atom, if you carefully see, it is marked as 2 equal to 6 minus 4 minus 12 into 4 equal to 0. That is a formal charge. Finally, the end of oxygen atom marked as 3 equal to 6 minus 6 minus 12 into 2, that equal to minus 1. Hence, we represent O3 along with the formal charge as follows in the diagram shown. We must understand that formal charge do not indicate the real charge separation within the molecule. In case it indicating the charges on atoms in the Lewis dot structure only helps in keeping track of the valence electrons in the molecule. Now, formal charges, whatever we have, formal charges helps in selection of the lowest energy structure from a number of possible Lewis dot structures for a given species. Generally, the